what are the sufficient conditions? So to find out or to write down the sufficient conditions, first of all we will form a Routh array or Routh's table. So what is a Routh's array or Routh's table? Let us look at here. Now we have the characteristic equation. What is that? Q of s is equal to a naught s power n plus a1 s power n minus 1 plus dot 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 up to an. Now basically this Routh's array will be in this form. You have a horizontal line like this and we have a vertical line. So here I have elements. Now, so it is like an array. We know that there are rows and columns. First of all, look at what are the rows we here. So we know that s power n is the highest degree. There are n number of poles or roots of the characteristic equation. So your first row I am going to name it as a s power n. The first row name is s power n. Then the next followed is s power n minus 1. Again s power n minus 2. Dot 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 up to s power 0. Therefore total how many number of rows? Starts from s power n and ending is s power 0. Total we have n plus 1 rows, right? So in any Routh's table there are n plus 1 rows where n is the order of the characteristic equation. Then what about the columns? So we need to calculate some of the column elements, and some of the column elements you can fill directly from the characteristic equation. Let us look at what are the elements of your s power n and s power n minus rows elements. Now, so we know that Q of s is equal to a naught s power n. So a naught is the quotient of s power n. So I will take the a naught and I'll fill it as the first element in this particular Routh array. The first element is a naught. The second row I'm going to take the next element a1, and the next element is a2. I'm not taking for next row. Instead I'm going to write this as the second element of the first row. Now what are the elements of the first row, s power n row? We have a naught, then a2. So for second row I have a1, then fill with the next element is a3, again a4, a5, a6, a7, which means so you have a naught, a0, a2, a4, all like even quotients will be in the first row, and the odd quotient a1, a3, a5 in the second row, which means first two rows of any Routh's array must be filled from the coefficients of the characteristic equation. Now total number of rows are n plus 1. Out of n plus 1 rows, 2 rows information is already available. We have taken from the characteristic equation. Then how many rows element we need to solve? Only n minus 1 rows. And again we need not calculate all the elements. So as the order is decreasing, the number of elements also decreasing. So it is going to be like a triangle. We have more number of elements in the first row and second row, and third row decreases, fourth row decreases. Finally when it comes to s power 0, you will be having only one element. Okay. Now let us see how to calculate for the third row onwards. First, second rows we already got all the elements from the characteristic equation. Let us take from the third, fourth, fifth and so on. First we will see the third row, that is s power n minus 2 row. So I am going to define the elements as b1, b2, b3 and so on. b1, b2, b3 are elements of my third row. Let us see how to calculate b1. So if you want to calculate b1, just look at the next above rows. So above rows are s power n minus rows, and what are the elements we should take? To calculate b1, b1 is the first element in the third row. So I am going to take a0, a1, a2, a3, these 4 elements, and from these 4 elements I can calculate b1. Let us see how to calculate b1. Let us take these 4 elements and write here. So when you write these 4 elements, it looks like a 2 cross 2 matrix. Now how to write b1? So b1 is equal to, I am going to start from a1, a1, a3, a1, okay, cross multiplication, therefore a1, a2 minus a3, a0 divided by a1. So generally when you write the determinant is opposite, AD minus BC we write. But in this case, if A, B, C, D, we have a reverse calculations like BC minus AD. So we should always take the first element. The first element is very important to me. In Routh array, the first column elements are very important. Therefore, when you calculate any element, so we should start with the first element only. So what is the first element? If you look at the row, first element immediately is the A1. So A1 minus A2, sorry, A1, A2 minus A3, A0 divided by A1. Similarly, you can find out B2 also. How can you write B2? B2, when you're writing B2, I am not changing the first two elements. They are same only. That means A0, A1 same only. But instead A2, A3, I am going to take A4, A5. Then what will be the calculation? So your B2 is equal to, I am starting from A1, A1, A4 minus B5, A5, A0 divided by A1. So those four elements, first two elements will be constant. They are fixed, and I am going to change the element as you go on calculating. Therefore, you can calculate like this. Okay. So what I can say now, to calculate B1, I am taking the elements A0, A1, A2, A3. Then the calculation of B1 is A1, A2 minus A3, A0 divided by A1. And calculation of B2, I am taking the elements A0, A1 and A4, A5. Therefore, B2 is equal to A1, A4 minus A5, A0 divided by A1. So this is a calculation of the third row. Similarly, we can calculate for the next row. Let us assume the next row elements are C1, C2 and so on. Let us see only the C1, so other things you can easily calculate. So to calculate C1, again look at those two rows just above the row where you are calculating. Now, what are the elements to consider to calculate C1? And above we have A1, B1, then we have A3, B2. Then what will be C1? Then we should start from B1. B1, A3 minus B2, A1 divided by B1. So this way you can calculate all the elements. Then finally you will get the last only one element. So we need to fill the complete Routh's array. So once you know how to calculate Routh's array, from this we can define what are the sufficient conditions. Let us say how to define the sufficient conditions. Now the first one, if all the elements of the first column of the Routh's array have same sign, then the particular system is stable. I said the first column elements are important, right? The first column element or the first elements of all the rows are important, and only the sign is important. Value is not, only sign. If all the elements having same sign, system is stable. That means if there are no sign changes in the first column. So if there are sign changes in the first column, first thing is we say system is unstable. There are sign changes means system is unstable, and number of sign changes will give us how many closed loop poles are there in the right of the S-plane, or how many roots of the characteristic equations are having positive real part. So positive real part is the right side. So we say my closed loop poles or roots are lying in right half of the S-plane. So all the thing in the Routh's array is, once the calculation is completed, you just look at the first column and not the values. Sign is important for me. So look at all the signs. If all the signs are same, my system is stable. Why the system is stable? If there are no sign changes, therefore there are no poles of the closed loop system or no roots of the characteristic equation are lying in the right half of the S-plane. We know that if there are no poles in the right of the S-plane, my system is stable. Now if there are any sign changes, yes, there exists some one or two poles in right of the S-plane, which means my system is unstable. So with the help of the Routh array, we can find out the stability of the system this way. Now look at sign changes here in this example. I am taking s power 4, s cube and s square, s1, s0. Then I am having all positives. value is not important for me, so I'm having all positive sign. Then from 1 to 1 you can check it. The first one to second one there is no sign change, second to third there is no sign change. Like that you can check it. There are no sign changes. Means what is the highest degree of S term? 4, which means that particular characteristic equation will have 4 roots, or that particular system will have 4 poles. All 4 poles are lying in left of the S plane in this particular example, because there are no sign changes, no poles lying in the right of the S plane. All the poles will lie in the left of the S plane only. System will be stable. Look at the second one. So in the second one I have plus, plus, minus, plus, plus. So in this case if you are getting like this, now first one to second one there is no sign change, but second one to third one there is sign change, because plus to minus I can take it as one sign change, and minus to plus again there is one more sign change. Don't think that since there is only one minus there is only one sign change. Sign change means plus to minus is one sign change, minus to plus another sign change. So there are 2 sign changes. What is the total number of poles? Total number of 4 pole. Out of 4 poles, 2 poles lying in right of the S plane, remaining 2 poles lying in left of the S plane. The closed loop system is unstable. So this way we can check the polarities of the first column elements. Now generally when you are solving the problem, we go up to maximum 6th order. If at all 6th order characteristic equation is available, let us see what are the possible calculations. Now take this example. So it's a generalized. Now characteristic equation Q of S is equal to, let us say I have A0 S power 6 plus A1 S power 5 and A2 S power 4. Now A3 S cube and A2 A4 S square, and we have A5S plus A6. So this is the complete characteristic equation of your system. Now, so this characteristic equation we form the Routh array. We just now seen how to form the Routh array. Now let us take the left side rows. What are the rows we have? S power 6, S power 5 and so on up to S power 0. So if you count total number of, we have 7 rows. So all 7 rows element we should fill. Now look at, out of 7 rows, 2 rows element directly we take from the characteristic equation. We can see here S power 6, S power 5, I am taking A0, A1, A2, A3, A4, A5, A6. So I am starting from the first element, highest degree A0. Then you fill the next element. Then you go like this and come down, go like this, come down. So it is continuous up to the last element A6. So 2 elements are over. Next, so we have S power 4 row. I am just defining it as a B1, B2, B3. That's it, right? So don't go beyond the B3 for this S power 4. Next, S cube. S cube will have C1, C2. Only 2 elements to be calculated. Now for S square we have D1, D2. Again only 2 elements to be calculated. And S power 1 we have only E1, 1 element, and S power 0, F1, 1 element. Now once we fill all the elements like this, let us see the calculations. Now in the calculations, the first one is B1. We know to calculate B1 we need 4 elements, A0, A1 and A2, A3. So directly I am going to write B1 as your A1, A2 minus A3, A0 by A1. That is the B1 calculation. And when it comes to B2 calculation, we have A1, A4 minus A5, A0 by again A1 only. Remember, the first element is important. So when you are calculating, starting with the first element and divided by the first element, right? Even the divided also by the first element only. First element calculations are important in Routh array, any Routh table or Routh array. Now coming to B3 calculations. When you look at the B3 calculations, interestingly, we have A0, A1 and A6 and there is no element. Therefore, you can take it as 0. Now, what will be the calculation? We should start from A1, A1, A6 minus B0, A0. Sorry, 0 into A0. There is nothing is there. So 0 into A0 divided by A0. So divided by A1. So what you will get here? You will get directly this element is A6. Means, so whenever there is element and below if you find any 0, that element is carry forward here. So you can look at the arrow. So from there to here you can carry forward. So you need not do the calculation for B3. B3 directly it is A6. Therefore, in this row, how many elements to be calculated? If the highest degree is 6, only B1, B2. And the formula is also very simple. Your A1, A2 minus B3, A3, A0 divided by A1. And B2 is A1, A4 minus A5, A0 by A1. Similarly, we will see how to calculate C1. When you calculate C1, it is B1, A3 minus B2, A1 divided by B1 alone, because B1 is the first element. Similarly, C2 calculations. Let us closely observe all the calculations. So C2 is, I have B1 A5 minus B3 A1 divided by B1. So in this row I have only two elements, C1 and C2. Similarly, you can calculate for the next S square D1 D2. What will be D1? We can write C1 B2 minus C2 B1 divided by C1. And D2, again if you want to calculate D2, look at that, and above already we have B3 below nothing is there, therefore that will be directly carry forward. So what will be D2? D2 is directly B3, need not calculate. Similarly, S power 1, there is only one element E1. What will be E1? So from C1 C2 D1 D2 you can calculate E1, that is a D1 C2 minus D2 C1 by D1, that will be the E1 calculation. Then finally F1. Again if you want to calculate F1, and if you look at the next row, the last element is 0, therefore the D2 is a carry forward. What happens here? A6 is carry forward to B3, and B3 is carry forward to D2, and D2 is carry forward to F1. So out of 9 elements, we need to calculate only 6 elements, 3 are directly available, and the first 2 elements are also available. So this way you can easily calculate the elements, and you can fill the complete Routh array. And finally investigate or observe the first column elements polarities. If all the elements having same sign, system is stable. If you have any sign changes, system is unstable. Number of sign changes gives number of closed loop poles lying in the rate of the S-plane, or number of roots of the characteristic equation are having positive real part.